University at Buffalo computer scientists have developed a tool that automatically identifies deepfake photos by analyzing light reflections in the eyes. The tool proved 94% effective in experiments described in a paper accepted at the IEEE International Conference on Acoustics, Speech and Signal Processing to be held in June in Toronto, Canada. The cornea is almost like a perfect semi-sphere and is very reflective. So anything that is coming to the eye with a light emitting from those sources will have an image on the cornea. Forensic expert says the two eyes should have very similar reflective patterns because they are seeing the same thing. It is something that we don't typically notice when we look at a face. When we look at something, the image of what we see is reflected in our eyes. In a real photo or video, the reflections on the eyes would generally appear to be the same shape and color. However, most images generated by artificial intelligence, including generative adversary network GAN images, fail to accurately or consistently do this, possibly due to many photos combined to generate the fake image. This new tool exploits this shortcoming by spotting tiny deviations in reflected light in the eyes of deepfake images. To conduct the experiments, the research team obtained real images from Flickr Faces HQ as well as fake images from the website thispersondoesnotexist.com, a repository of AI-generated faces that look lifelike but are indeed fake. All images were portrait-like, real people and fake people looking directly into the camera with good lighting and 1024 by 1024 pixels. The tool works by mapping out each face. It then examines the eyes, followed by the eyeballs, and lastly the light reflected in each eyeball. It compares in incredible detail potential differences in shape, light intensity, and other features of the reflected light. While promising, this technique has limitations. For one, you need a reflected source of light. Also, mismatched light reflections of the eyes can be fixed during editing of the image. Additionally, the technique looks only at the individual pixels reflected in the eyes, not the shape of the eye, the shapes within the eyes, or the nature of what is reflected in the eyes. Finally, the technique compares the reflections within both eyes. If the subject is missing an eye or the eye is not visible, the technique fails.